Hi, I'm recording Unit 2, Lesson 5, multi-step equations and variables on both sides. It's kind of a long one, but I go through some tips and tricks, and I'll try to edit the video and identify those as I go through. So if at any point you understand already, of course you don't have to listen to me, but sometimes I show you something that you may not have known. Okay, so first I'm going to start with two-step equations. Two-step equations are just that, like our one step. Now we have two steps. Now I'm using my pen. Let's see how this works. So the first step is adding 2. And so you could do your equations this way, that imagine a line where the equals is. And our next step is to divide by 5. Another way you could do it is to just know that when something crosses over this equal sign, it changes sign. So I'm just going to put a -3 here, get rid of it there. I get -7 equals 7x. Now division, you divide by 7, get rid of it there. -1 equals x. Now the variable could be on either side of the equals. There's still just 2 steps there. I subtracted 3 and divided by 7. This one I wanted to show because this is an example. This is a trick. I don't like calling it a trick, but so whenever you have fractions like this, you could rationalize the denominator by multiplying everything by something that each of the denominators could divide into. And then we'll get rid of all the denominators and we won't have any fractions. You could always do this whenever you have a fraction. Now, just to note that 2/3 r is the same as 2r. Oops, where's my pen? Did it go away? There it is. Oh, it's spinning. 2r over 3. Maybe if I switch it up. So it's the same as 2r over 3. Those are the same things because under this r is a 1. So these two things are the same. Anyway, back to this. So what number can I divide by 3? I could divide by 4. I could divide it by 12. Well, that number is 12. So I'm going to multiply that by 12. I'm going to multiply that by 12. And I'm going to multiply that by 12. Now, if you remember fractions, now you could actually multiply and divide, or you could simplify it. So I can multiply 24 and divide it by 3, which is 8, or I could simplify this and know that 12 divided by 3 is 4, 12 divided by 4 is 3, and 12 divided by 12 is 1. So that last one just goes away. So then our denominators are gone, and I get 8r plus 9 equals 7. Now we do our 2 steps. Subtract 9, -2, and divide by 8. So r equals -1/4, which is -2/8. Even if you just have one thing as a fraction, you just multiply everything by the denominator. Okay, so those are 2-step. Now, before we do multi-step or the variable both sides, this would be considered actually a multi-step right here. This is a multi-step because we have to do a simplifying before we solve. Now, there's so many things here. So we got to look at the left side. What can I combine? I could combine these two and I get 13x minus 21 equals -15. Now, I could do the 2 steps. Add 21. Oops, I clicked. Where's my 1? And then divide by 13. Now, I'm not showing every step here. I can. You could think of this line. Add 21. That goes away. Add 21. 13x equals 6. Divide by 13. Divide by 13. X equals 6/13. Here's It's spinning. There's another one to simplify. And what do I need to simplify? I need to multiply this negative, distribute the negative. So I get 10y minus 4y minus 8 equals negative 20. So this is 6y minus 8 equals negative 20. Oops. Now I add 8. 6y equals negative 12. What times 6 is negative 12? Negative 2. Okay, so the objective today is solve equations in one variable that contain variables on both sides. So what we've been doing so far, the variables on one side. What we're going to do now is solve with variables on both sides. So to solve it with both sides, first you collect your terms on each side. You simplify each side as much as you can before you start solving and start moving things across the equals and adding and subtracting, doing the opposite. So you want to make sure each side of the equation is as simple as you could get it. So here we have an n on both sides and numbers on both sides. It's your choice. I always start with the variable, but it's your choice to do either one first. So first, since this side has a bigger number of n, I'm going to move this 5n over to the left. And each side is as simple as it gets. I cannot combine those. I cannot combine those, so I'm done there. So I get 2n minus 2 equals 6, and now it becomes a two-step equation. And that's what we're trying to do, simplify everything that it gets to a two-step equation, and then go down to one-step equation. So now I have a two-step equation. So the 2n is good where it's at. I'm going to move the 2. So 2n equals 8, n equals 4. Now, another thing you should try to get in the habit of, especially when the equations start getting longer, this one isn't as long, is checking your answer. So to check our answer, we could do 7 times 4 minus 2. Does that equal 5 times 4 plus 6? So this is 26. This is 28 minus 2, 26. So we're good. There really should be no reason you miss an equation problem, because you could always check your answer and see if you're right in the first place. Okay, so this one, a lot of people get confused because we have b's and the 2 is okay where it's at. So if you move the 2, you still have to move the b. I know a lot of people get in the habit of putting the variable on the left side, but it could be on either side. So since this b is alone on this side, the 3b, I'm going to minus 4b minus 4b. And I get 2 equals negative 1b. I'm going to write a capital because it always looks like a 6. So that is negative b. I don't want negative b. I want to know what positive b is. Now you could think of just take the opposite. The opposite of that is b. The opposite of that is negative 2. But when we are taking the opposite, what we're really doing is multiplying or dividing both sides by a negative 1. And that's how we get the answer. So whenever you have negative b, just take the opposite, and that will be your answer. I'm going to call it a trick, but just opposites whenever you have a negative. Okay, this next one, simplify. We're looking only on the left side here. I could combine those, and I get negative 2a. And then on the right side, I have to distribute that negative 5. The negative goes with the 5. So the negative 1 stays where it's at. And then I get negative 35 plus 10a. Now I could combine these. So I get 4 minus 2a equals negative 36 plus 10a. Now, this side has a larger number of positives, so I'm going to move the 2a. Remember when I talk about sides, it's where the equal is. So I get 4, and this side I get negative 36 plus 12a. Now I move the 36. Now, whatever you decide to do first, so many options. You could move the 36 and then the 2. You could move the 10 and then the 4. We should all end up with the same answer. Now it's a fraction because I divide by 12. 12 doesn't go into 40 equally. So it's 2 6/20ths? No, 3. 3 goes into 12. No, not 3. 4. 4 goes into 12 3 times, and 4 goes into 40 10 times. So that's your final answer, 3/10. All right, here's one with fractions. Remember what I said, we can multiply by something that we could be both divided it by. So this one, so you could multiply the 1/2 and get 1/2 b and 3/2 b, but look at both sides have division by 2. So I can multiply this by 2, this by 2, and just once here because it's going to be distributed. So you only work with a fraction. So when I multiply by 2, that divides, and I just get 1 and b plus 6, which is just b plus 6. Here, the 2's cancel, and I get 3b. And here is negative 2. So on this side, I have b plus 6, and then 3b minus 2. Now, I'm going to move the b, your choice on what to move first, 2b minus 2, move the 2. These are all ended up as fraction answers. So b equals, 2b equals 8. No, they're not fractions. 2 times what is 8? 4. Okay, here, this side I could combine 15 and 9, negative 9. This side I have to multiply the 2, distribute it to both. So then I subtract 2x. X plus 6 equals 4. You could probably work it from here. What plus 6 is 4? 6 minus 2 is 4. So x is negative 2. So when you're solving equations, there's two things that could happen. You could get an identity. It's true for all values. That means you end up with something that is true. You get something like 7 equals 7, or 5 equals 5, which is true. These numbers always equal each other, okay? 81 equals 81. Your variable kind of goes away and you're left with two numbers that are equal to each other. That's an identity because it's always true. So vocabulary is very important here. Contradiction is one that is not true for any value. There's no matter what I get in there, I'm not going to get an answer. So what we've been doing so far are we're finding an answer. We're getting one number as an answer for all of those equations before now. Now we're going to do some with identities and contradictions. Now contradictions, you end up with something like 3 equals 7. Is that true? No, 3 does not equal 7. Those are contradictions. Or 81 equals 0. Nope, that's not true. Okay, so those are contradictions. So when solving an equation, the numbers here, it is that you end up, you go through and you get something like this, 3 equals 3. But in algebra, what happens, you have the same number of x's on both sides. You get the same thing equal to itself. You could tell right here it's an identity because both sides have the same thing, both sides of the equal. So this is an identity. Contradiction, like this right here, 1 equals 3. Nope. And this one, when you get rid of the x, 0 equals 3. That is not true. And right here, you could see it's a contradiction because you have x on both sides, but you don't have the 3. So here, we got to simplify each side. 9 minus 5x, because I'm combining the 10 and the 1. Oh, that's not 9. That's 11. I don't know if you heard my phone. I pressed screen call. So many solicitors. Equals, and then I combine those two, negative 5x plus 11. Now right there, I have a negative 5x, 11, 11. I have the same thing on both sides, but if you want to go the step further, those are going to cancel, and I get 11 equals 11, which is identity. No, so identity means any number I put in for X, I'm going to get, it's going to work out. It's going to be true, no matter what number. So there's infinite amount of numbers I could put in. It's always going to be true. A contradiction means it's never going to be true. So this one probably is a contradiction. So we add those, 13x minus 3, and we add those, 13x minus 4. So we could see right there, they're not the same. But when I get rid of 13x, I get negative 3, oops, that's a 3, equals negative 4. Not true. So they're not equal. A 0 with a line through it is called the null set. That means there's no numbers that will make this true, null. That's what that symbol means, 0 with a line. I know not so much anymore, but people used to draw a 0 with a line through it. So I'm going to put vocab there, null. Okay, so here's one more, 3y plus 7 equals 10 plus 3y. Do you think it's true or not? The 3y is the same, they're going to cancel. 7 is not equal to 10, so it's the null set. No value I put for y, it's never going to be true. Here's another one, 3c plus 7 equals 3c plus 7. I could see right there they're the same. They're identity. So there's infinite a number of answers, or you could say identity. Okay, here are some word problems. John and Sarah are planting bulbs. John has planted 60 bulbs and is planting at a rate of 44 per hour. Sarah planted 96 and a rate of 32 per hour. And how many hours will John and Sarah plant at same number? When it's same number, you put each equation equal to each other. So we have this 60, this is John, 60 plus 44 an hour, the same as means equal, 96 plus 32 an hour. So here's our equation that we want to solve. Okay, so they already did the 32. I copied that down. So if I minus 60, 12b equals 36, that's a capital B. B equals 3. So 3 hours. When you have a real world or word problem, think about what they're asking. They're asking how many bulbs, I don't know, I could do orange. How many bulbs? Oh, and how many hours will they get the same? So that's what we answered, in 3 hours. And then a second question, which I don't think I answered, is how many bulbs will it be? So my first answer is 3 hours. How many bulbs? So all you do is plug in your answer here and find out how many bulbs. So 60 plus 44 times 3, and it should be the same, 96 plus 32 times 3, which I probably can multiply better. So this is 120, 132, 60 plus 132, 192 bulbs. Those are flowers that you could plant if you don't know. Okay, so the other one is 96 plus 32 times 3, which is 96 plus 96. 90 is 180, 192. Yes, I got it both for. So this is the second answer, and this is the first answer. Make sure you use units. 4 times Greg's age, so 4 times decrease subtracted by 3 is equal sign, 3 times increase by 7, add 7. So here's our equation. So they subtracted 3g, I get negative 3 equals 7. G minus 3. So what are we looking for? How old is Greg? So we're looking for his age. So age is in years, right? So if I add 3, Greg is 10 years old. Okay? Make sure you write what they're, make sure you know what they're looking for and you write your answer as such. You could even write a sentence if you'd like. That would be awesome. Okay, here's a lesson quiz. I left the answers on there if you want to try it. Your assignment is a PDF. You are to do all the even numbers, and I'd like to see the questions written with the answers, please. Thank you. Let me see if I could stop the recording.